Hello everyone, in this video I'm going to go over some hard integrals, some hard trigonometric integrals that are very useful to some computations. So first I'm going to start with secant of theta to theta, and then I'm going to jump to secant cube and secant to the 5. You can extrapolate these techniques to some of the powers of single trigonometric functions. But now let's go ahead and see what happens. So if we have secant of theta to theta, by itself is very difficult to do anything with it. It's just 1 over cosine. We don't have the sine, so we cannot do anything else. So what we'll do is we're going to say, well, I'm going to multiply secant of theta by secant of theta plus tangent of theta up and down. So this is like multiplying by 1. And now I'm going to make a substitution. U equals secant square plus secant by tangent. Notice that that's pretty much, sorry. I was thinking about the du. I'm going to make u equals secant of theta plus tangent of theta. And so the du, of course, is going to be secant square plus secant by tangent. The derivative of tangent is secant squared. The derivative of secant by tangent. And why I was thinking about that? Well, because this is precisely what I get here. This is secant squared plus secant by tangent, the theta. So as you can see, I have the du on the top, and I have the u on the bottom, and this is simply the integral of 1 over u du. And so this becomes log of absolute value of u plus c, and then I have log of secant of theta plus tangent of theta plus c. Okay? So that's the first integral. That's something that I can simply do by having substitution. Okay? Now let's transition to exercise number 2. Which is going to be, how do I do secant cube? Secant cube can be seen as if I have secant of theta by secant square. And what I'm going to do now is I'm going to do parts. I'm going to do dv is going to be secant square of theta to theta, since you can kind of see here the secant square, and so that will give me a b equals tangent of theta. And then I'm gonna do u equals secant of theta, and then the u is gonna be secant by tangent. Now, because I do this substitution, then this integral secant cube becomes u times b, which is tangent of theta secant of theta minus the integral of b du, which is secant of theta tangent square of theta, the theta. But now I can transform tangent square into secant square minus 1. And so this becomes secant cube of theta minus secant of theta. Okay? Remember, tangent square is secant square minus 1. So multiplying by secant, it becomes secant cube minus secant. And so what happened is that because I have this secant here with a negative, then I can take this piece and I can take it to the other side. And so what I'm going to have now is that twice secant cube of theta is equals to what? Tangent of theta secant of theta plus the integral of secant of theta to theta. Notice that fortunately we just did that one. Okay, we just did that one here, and so I can use it now, and I'm gonna have that the secant of theta cube is tangent of theta secant of theta plus a log of secant plus tangent of theta plus c. And because this was twice, then I can divide everything by 2. Okay? So now you kind of see a trend where the previous integral is going to be used in this one. Same thing is going to happen on the next one. So this is number 2. And now I'm going to go with integral number 3, which is going to be secant to the 5 of theta, the theta. And so you can probably suspect that I'm going to do a similar play here. And you are not wrong. This is secant cube of theta times secant square. And I'm going to try and integrate that. So dv secant square, which is going to give me the tangent. And now my u is going to be secant cube. And so the du is going to be 3 secant square of theta, and then the derivative of secant is going to be secant by tangent. So as you can see, very convoluted thing. I'm going to get here 3 secant cube tangent of theta. So let's see if that part is actually going to pay off. I have u times b. I'm going to have tangent of theta secant cube of theta minus the integral of b du. So b du is going to be 3 times secant cube tangent square. Okay? And so I can do the same play again. And I'm going to have, well, this is tangent of theta, secant cube of theta, minus 3 times. And then notice that this is going to become, tangent square can be secant square minus 1. So this becomes secant to the 5 minus secant cube. And so I just did it again. And now, what that means is that the integral of secant to the 5. By the way, I have 3 of those here, so I can move it to the other side, and now it's going to be 4, right? And that'll be tangent of theta secant cube, and then plus 3 times the integral of secant cube. So notice that there is some sort of kind of like symmetry going on in there, but I can put everything together now. I'm gonna divide this on the other side. And I'm gonna plug what I'm getting from the other integrals. Notice that I got this here. So this will be tangent secant cube of theta plus 3 times tangent of theta secant of theta plus the log of secant of theta plus tangent of theta. And this part is over 2. Okay? And plus c, of course. So because this is 4 times, then I multiply, and I get that secant to the 5 of theta is just going to be, I want to put everything over 8, so I'm going to put a 2 here and a 2 below. So it's going to be 2 tangent of secant cube of theta plus, and then same thing here, 3 tangent of theta secant of theta plus log of secant of theta plus tangent of theta, and everything now over 8. Okay, since 2 by 4 is 8, and I put a common denominator here before, so I'm able to multiply that there. Okay, so this is secant to the 5, and as you can see, it can get larger and larger. You could probably go secant to the 7, and it's going to be in terms of secant to the 5 because it's the same technique. But we're going to use in this integral in some of the examples this week, so that's why I'm showcasing how to do these integrals.